their constants has a remainder of negative 95 when divided by x plus 2. Okay? So I'm just writing down the key information. Divided by x plus 2, remainder is negative 95. Right? And then has a remainder of 3 when divided by 2x minus 3. Remainder. Okay. We want to find the value of A and B. Okay, we got to make use of the individual pieces of information. So what can we do? Jaden, what have you tried? Ask for this question, right?
I put x equals to negative.
Okay, so let's define fx with this first. Okay, so when x equals to negative 2, what do you get? You substitute, right? Okay, and simplifying this, what is that? Negative what? 73 plus 4a minus 2b. That's all? Okay, so what is this equals to, Jaden? I simplify already. Then this expression itself, what is the value that's equal to? Negative 95, okay? Because there's a remainder, right? So we get this one equation. We can simplify it further. We will get 4a minus 2b equals to negative 95 plus 73. So this will give us negative 22. Okay? You can simplify this further, even further by dividing by 2 across. So you get 2a minus b equals to negative 11. So b is equals to 2a plus 11. So you get one equation, okay, from the first piece of information. Then from the second piece of information, you can get another equation where you let x be equals to 1. So you know what you get. When x equals to 1, will you have your remainder to become 3? Sorry? 3 over 2, right? So x equals to 3 over 2. Then do the substitution. Okay. Then you do your calculation. Sorry, may I know what is the simplification? Can someone tell me? Sorry, 8 what? 27. 9 over 4a, right? Then plus 3 over 2b. Okay, and this will be equals to 3. Sorry? Oh, minus 9. Okay, I thought this one already. So 27 minus away 9, you will get 18. So this will be equals to 3 because the remainder is said to be 3. Okay, so we can simplify this. Maybe you want to bring 18 over first, so you get negative 15. I don't enjoy dealing with fractions. Okay, so in this case, because it's an equation, I can multiply across by 4. So I will get negative 60 equals to 9a plus 6b. I multiply across by 4. So I deal with integers only. Okay, then this can be my second equation, and then after that, we solve simultaneously. Okay? Questions? Ellen, you appreciate your computer to be now. Okay, so I will not proceed to solve for A and B. Okay? I think you can solve this simultaneously. Right? Next, question 14. Okay, question 14, they gave you an expression ax cubed plus bx x squared plus 2x plus c, said that the remainder when divided by x minus 1, okay, is actually twice that. So is will represent equal sign, twice mean 2 times when it is divided by x plus 1. From that simple statement in the question, we want to show that c is equals to 3a minus b plus 6. So, objective is to show 3a minus b plus 6 equals to c. Okay, so same sequence of steps actually. We let fx be this. So we focus on getting the remainder when divided by x minus 1. What should we substitute? X should be equals to 1. Okay. So f1 will be equals to a. So for 1 is easier lah. 1 to power anything is just 1. So a plus b plus 2 plus c. Okay, so this is the remainder. And then when divided by x plus 1, that will mean our x should be equals to negative 1. Okay. So I will get negative a plus b minus 2 plus c. Right? So we keep to this structure that we have in actually creating our equation itself. Okay. So we need to remember that there is this 2 times over here. Yeah, just this by x plus 1. Okay, so forming our equation, I'll erase this, yeah. Okay, so when divided by x minus 1, this is our remainder, which is a plus b plus 2 plus c. And then it's equals to 2 times. So 2 times the remainder when divided by x plus 1, which is negative a plus b minus 2 plus c. Essentially what the question wants you to do is to make c the subject. Okay, so c is the single one on the left hand side. So we do the manipulation by first expanding this. Okay, and then we can keep the c to one side, shift everything to the other side. Okay, so maybe you can keep the c on the right side and shift everything else to the left. You won't be able to get this. So I leave that manipulation for yourself. So I hope you notice that whenever we deal with a problem in exercise 4.2, we really have to be able to segment the question, segment the sentence to identify each phrase in the question itself. Okay, so that you know what is it that you need to do. Okay, so like over here in question 9, I segmented it by recognizing this important information divided by x plus 2, remainder is this. Then after that divided by this, remainder is this. Okay. While for question 14, I noticed that okay, the question has given me an entire equation due to the word is. Okay, is will represent to be equal sign. So on the left of the word is, that is 1 second, which talks about a remainder when divided by x minus 1. And after the word is on the right side of the paragraph, okay, it says about twice that of the remainder when divided by x plus 1. So I use that, okay, to form the structure that I need that will guide me in terms of my solving. Okay. Then last one, question 17. The function f is defined by this. Where a and b are constants, given that x x squared minus 3x minus 4 is a factor. Okay, we want to find the value of a and b. Okay, what did we say about when we have a quadratic factor? What do we need to do? We need to factorize, right? So x squared minus 3x minus 4 can be factorized into x minus 4x plus 1. Okay, you do your first method, right? Okay, then we get x minus 4x plus 1. So because this is a factor, it will mean that x minus 4 is also a factor, x plus 1 is also a factor of fx. Okay, so we need to take it out individually, right, for us to apply our factor theorem. So when x is equals to 4, due to your x minus 4 factor, okay, our fx, our remainder, will actually be 0. Okay, 4 to the power 3, 64, right? Okay, so we will get 66a plus 16b minus 20. So this is equals to 0. Okay. In other words, to simplify this, 66a plus 16b is equals to 20. I believe it can all be divided by 2. So I'll get 33a plus 8b equals to 10. Okay. Always try to simplify your equations to make it more manageable for you to solve rather than having to deal with large numbers. Okay. Then we look at x plus 1 when x equals to negative 1. A plus b plus 5 plus 2a. A plus b plus 5. So likewise, this is remainder 0 because it is a factor. So in other words, a is equals to negative b minus 5. So we solve it simultaneously. Okay, do your substitution method, and then you will be able to get the answer. Okay, I leave it to you to get the answer in a minute. Then part 2 asks you to factorize fx completely, and it says hence. So may I know what is the value of a and b that we should get? A equals to negative 6, thank you. Okay. A equals to, never bring your homework, you can memorize answer. A equals to, is it? Okay. Negative 7. Okay. Alright, so A equals to 2, B equals negative 7. That means our fx, right, is 2x cubed minus 7x squared minus 5x plus 2 times 2. So that will be 4. So I'll simplify this. So this is my fx. Okay, so to factorize it, right, we actually already know one of the factors. Okay, x squared minus 3x minus 4. So what you got to do is long division. Okay. So doing long division, divide by x squared minus 3x minus 4. Okay, we will have x here minus 6x squared minus 8x minus 7 plus 6x squared minus 3x plus 4 minus 1. So minus x get this in your long division. So your fx is equals to x squared minus 3x minus 4, the divisor, multiplying by the quotient. Okay? But they want you to factorize completely, so your x squared minus 3x minus 4 needs to be factorized into x minus 4 times x plus 1. Okay, so this will be the answer. Okay, question? And okay, if you're good, will you submit your homework to the front? Right, so yesterday we were looking at chapter 4.3. Okay, then in chapter 4.3 itself, we have addressed a few questions yesterday. Okay, first of all, it is about factorizing your sum and difference of cubes, your a cube plus b cube and a cube minus b cube, for which I told you that we can use our SOAP acronym, okay, to remember the symbols. Same symbol first, then after opposite symbol, then after always positive, so SOAP. Okay, then after that, we have also learned how to factorize cubic polynomials and also solve cubic polynomials, for which the steps remain the same, just that in part 2, okay, factorizing, we're dealing with expression, and then in part 3, we're dealing with equation. So the steps is to first find out the linear factor, okay, while we have tried to find an easier way around it by using the calculator. Okay, we still need to show that we are able to apply the factor theorem. Okay, so we're just trying to find a shortcut around our trial and error method. Okay, then after that, step 2, it is to perform your long division, and then step 3, we need to ensure that we factorize completely before solving. Okay, so just to recap what we have learned, I thought that we want to start off our lesson today by looking at exercise 4.3. Question 6 first. Okay, where we want to factorize completely. Okay, although it says factorize each of the following polynomials, we should always factorize completely. Part A as well as part C. Okay, we look at these two expressions. Okay, so how do we factorize this? Okay, let's look at part A first. Any ideas on how to factorize this? We're looking at factorizing. In this case, hint to you is that we're trying to use the sum and difference of cubes. Okay, not about using the calculator and all that. Okay, how can we use the sum and difference of cubes to factorize this? We take out x first, right? Okay, so our principles when it comes to factorizing should remain the same as per what we learned in Sec 2. We should always try to factorize common factors first, extract any common factors. In this case, what is a common factor? Is it just x? X, okay, and what is that? X cubed and 27. Okay, do you see that we have the sum of cubes? What is 27? 3 cubed, right? Okay, and then we can now apply our sum of cubes to get x plus 3, same first, then opposite, then always positive. Okay. So we get this as the answer. Can we further factorize it? No, okay? Because if it could be further factorized, then over here, your formula for sum of cubes could be further factorized. Okay. not, right? Because this is a cubic expansion, will be challenging, very tiring, okay, and not necessary as well. Okay? I think in this particular form, we can see very clearly that we can use our difference of cubes. Just that the A will be x plus y and B will be x minus y. So we got to be very careful in the way we apply our sum and difference of cubes. So A cubed minus B cubed over here. So our formula tells us that we are going to get A minus B, A squared plus AB plus B squared. So in other words, A is x plus y, B is x minus y. This is the first set of brackets. Second set of brackets, I have A to be x plus y, AB to be x plus y, x minus y, and then B will be x minus y. So it requires big focus to make sure that we do the substitution correct. Okay? Do we need to simplify this? Yes. Okay? So for the first set of brackets here, I will have x plus y minus x plus y. Okay? For which it is just y. Because x minus x is 0. And then y plus y, we get 2y. Okay? Then in the next, more elaborated set of brackets, okay, do we need to expand the x plus y bracket square? Yes, unfortunately. Okay? Which explains why we need to know how to expand this quickly by using identity rather than sticking with our breakpoint method. Okay? So x plus y times x minus y is your x squared minus y squared. Okay, so this leads to this, and then this leads to this, and then this leads to this. Right? Then simplify it. X squared plus x squared plus x squared, that's 3x squared. 2xy minus 2xy, there's no more. Y squared minus y squared plus y squared, again, we get a single y squared. Okay, so for simplifying, we get this. Okay, questions? Right? Then, so we have revisited our sum and difference of cubes. Next thing I want to revisit is our solving of cubic equation, which technically also relies on your factorizing of cubic polynomials. So looking at try 17, we want to solve this and take note, leave your answers in insert form. When necessary. Okay? So we need to learn how to leave our answers to exact. Okay? The reason why you will get answers in insert form is because you will eventually be solving something quadratic, and for the quadratic part, you got to apply the quadratic formula, and then you cannot press the calculator directly. You got to leave the answer in insert form. Okay? Would I give you about 5 to 6 minutes or so, right, to solve this question on your own? Okay? I'll give you 5 minutes first. You may want to check your answers with what I have on the whiteboard. Okay, just to run through it. Step 1 is about finding linear factor. So I saw that some of you had a bit of a rough start figuring out how to find the linear factor. So remember, we have to use a calculator and choose the one that's an integer. Okay. Okay, we don't choose the one that's fraction because not intuitive. Okay, and then we will be able to say that x minus 1 is a factor. Why is this a factor? Because to get x equals to 1, it means that x minus 1 is equals to 0. Just bring it into the left. Okay, and that tells us that that is a linear factor. That is how I'm setting for factor theorem. Then step 2 is to perform the long division, okay, such that we can say that our polynomial fx itself is expressed as x minus 1 times x squared plus 6x minus 3. Okay, following our divisor, quotient, and then remainder format. The remainder is 0, that's why there's no need for us to write plus remainder. Okay, then to solve it, because we're trying to solve fx equals to 0 actually, so since our fx can be factorized into this manner, I can write it as this is the equation to solve. Then we can do our zero product rule to say that x minus 1 is equals to 0 or this equals to 0. Okay, this one can't be solved by factorization. You got to use your quadratic formula. Okay, you can take that hint from the way the question has asked, because the question asks for your answer to be insert form. So naturally, you should be using your quadratic formula. Okay, but even if you see that, even if the question can be factorized, right, you want to do the quadratic formula also perfectly fine. Okay, you find that quadratic formula is the ultimate most powerful formula in terms of solving quadratic equation, because you don't need to bother whether it's factorizable or not. Okay, don't need to check all of that. Okay, so quadratic formula is the most powerful one. Okay, then you get this answer. But my question here is, do we need to simplify further?
Yeah.
Yes. Okay. Your square root of 48 being a third still needs to be further simplified. Okay. So 48 is divisible by 16, right? Okay. So 16 being a perfect square and 48 divided by 16, you will get 3. Okay. So 4 on the outside because square root 16 is 4. And then you have this 6 and 4. Okay, has common factor of 2, so can be further simplified to be negative 3 plus minus 2 to 3. Okay, so there are actually 3 solutions in total, in case you're wondering why 3. Down here has 1 solution. Over here is actually 2 solutions because one is plus, the other one is minus. Okay, so maybe to draw out the clear distinction, okay, I'm seeing as 3 solutions in total. Right? Okay. Questions? Right. I know the weather is very warm and some of you are getting very tired. You have to find a way to keep yourself awake. Okay. So if you need to walk around behind the classroom, although I know Shannon you cannot walk, okay, but I don't think you'll be the one sleeping. Okay, but if you need to, please take a walk behind the classroom. Right? With this solution, I also want to emphasize on one thing. Okay, my question here is quadratic equation. How many solutions are we expecting? Maximum of 2. Okay, it is not always 2. Sometimes you can have 0. Sometimes you can have 1. That's what we learned in chapter 1 and chapter 2. Cubic equation, maximum of 3. Is it possible to have 2 solutions only? Yes, we saw yesterday, right? Okay, whereby one of the factor is repeated. Okay, x plus 3 bracket square. Okay, so that is possible. Is it possible to have just 1 solution? Technically, yes, we can only have 1 real solution. The other one, okay, where did the remaining 2 go? Okay, it's actually a complex solution, not solvable. Okay, not solvable in our current needs. Right? But in future you can. Yes. Possible to have 2 solutions, possible to have 1 solution. Is it possible to have no solution though?
Yeah.
I think in our current context, maybe not. Okay, I'm trying to run through the graphs, possible graphs that we have. I don't think it's possible to have no solution. Okay, maybe when we go through EMATS chapter 5, our graph of a cubic graph will look like this. Okay, and we are going to draw it. Okay, you all don't just okay, a bit like that also. Okay, or another shape is this shape. Okay, so yeah, no more curves for you to draw. Okay, alright, so I think based on what I'm running through my brain now, I don't think that it's possible to have no real solution. Okay, so it's at least one real and two complex. Okay, one real, minimally one real solution. Alright, so let's now look at try 18. Okay. Okay, what does this make you think about? Discriminant. Alex. What is less than 0? Discriminant less than 0. Okay. Yes, we are expecting to talk about discriminant, but what is one very important thing about discriminant? Discriminant only applies for what kind of equation? Quadratic. Okay, this is a cubic equation, right? Because when I expand this, x times x squared, I'll get x cubed. So we cannot have a definition of discriminant for a cubic equation. Okay? But eventually we may need to use it. Okay? To justify that there's only one real root. Okay? So first of all, when we have this equation over here, what would you naturally want to do? Expand, right? Okay, and then simplify. So expanding it, I will get x cubed plus 6x equals to 3x squared. So we get this, right? Then the steps remain the same. Okay? I'm not going to bore you with the same steps again, so I'll just do it onto the whiteboard. Use your calculator. Okay, x equals to 2. We find that it is equals to 0, so x minus 2 is a factor. Then perform long division. So take the expanded form to do the long division. Minus 3 plus 2. Gives us our x equals to 2. Okay, so that is one real root already. Okay, so what we need to show now is actually this quadratic equation, will there be any real roots? Okay, this one does not have any real roots. So which explains why, okay, just like Alex was saying, less than 0. Okay, because this should not give us any more real roots. Right? Since the question has really hinted us to us that way. So we can go and find the discriminant. minus 16, that is negative 15. That is less than 0. Okay, so on this segment itself, we say that hence x squared minus x plus 4 equals to 0. This particular quadratic equation has no real roots. Okay, to avoid trying to truncate your words, okay, truncate your explanation, right? Be very clear that we say that there's no real roots for this particular equation. Okay, so specify the equation. Okay, then overall, I can now conclude that therefore, okay, x times x squared plus 6 equals 3x squared plus 8. That's only one real root. Okay, always remember to end off with a conclusion. And then show. Polynomial gx meets the x-axis at these three values and passes through the point 0, 12. Okay, they want you to find an expression for gx. So it's about doing things in reverse now. Okay, but of course, I'm not telling you that based on the final answer here, we work backwards, do some reverse long division and then get to gx. No. Okay, we just have to reverse our thinking a little bit. Okay, and that means that we need to break down this question to understand what does it actually mean. Okay, so when we say that the cubic polynomial meets the x-axis at negative 2, 1, and 2, what can we say about these three values? They are considered what? On the graph itself. I never introduced to you the graph yet, right? Okay, so we're not going to talk about the graph. The other? X-intercepts, right? Okay, so negative 2, 1, and 2 are x-intercepts. Agree? Because it meets the x-axis at this value. Okay, what is an alternative interpretation of x-intercept? Roots. Okay, so they are also considered to be roots. Right? Okay, with roots itself, okay, it will mean that my gx, okay, when it is equals to 0, I'm able to say that my answer when I solve it is going to give me x equals to negative 2, or x equals to 1, or x equals to 2. Correct? Okay, this is our understanding of roots. Roots is a solution to an equation. Okay, how do we usually get this? So let's look at the reverse process of our solving. How do we get x equals to 2? It is because we were solving x minus 2 equals to 0. How did we get x minus 2 equals to 0? Because of the factorization, right? So, what can we say about this? Before that, what is the step before? X plus 2 equals to 0. Right? X equals to 1, what can I say before x? Okay, or x minus 1 equals to 0. And then x equals to, what can I say? X minus 2 equals to 0. So how should the factorization of gx look like? It will be x plus 2, x minus 1, x minus 2 equals to 0. Right? We are working backwards, right? Okay? But is that the answer? Does this mean that gx is going to be this? No. Because actually there's another information. They tell you that it passes through the point 0, 12. Okay, so what does passing through 0, 12 mean? What does it mean? Y-intercept, okay, yes, y-intercept. It also means that when x is 0, my output y should be equal to 12. So that means that if I substitute in 0 for my x's, the value that I'm getting should be equal to 12. If I claim that gx is going to be x plus 2, x minus 1, x minus 2. But is that true? No, right? Because when I put x to be equals to 0, I will see that I will get 2 times negative 1 times negative 2. That is equals to 4. Not equals to 12. So something's not right, okay, in my process over here. Okay? It will mean that maybe there is a coefficient, something else that I need to multiply with in order to get this solution. Okay? So I cannot assume that there is a 1 over here. So naturally you think of 3. Because 3 times 4 will give us 4. Okay? So it is with this thought process that we are able to see that the answer is going to be 3 times x plus 2, x minus 1, x minus 2. But of course, how to present our answer? Right? All my working over there is just for me to show you, okay, the understanding behind it. Right? So how to present it? I'll write it here. Okay, we know that it is cubic, so obviously over here when we form this, okay, we already get a cubic thing. Right? So we will be able to say that gx, okay, is equals to a times x plus 2, x minus 1, x minus 2. Okay, so right at the start, you can already get gx to be equals to this. How we got the factors, just for your note-taking purposes, okay, this is due to x equals to negative 2, 1, or 2, and 2 are roots to gx equals to 0. Okay? So we cannot assume that there is no coefficient to x cubed, or rather that the coefficient of x cubed is going to be equals to 1. So you need this to hold, okay, the statement, the entire conditions to be true. Okay, so you need this part here, the A. Because cannot assume coefficient of x cubed equals to 1. Right? So then now we put in the 0, 12. So at 0, 12, 12 is equals to a times 0 plus 2, 0 minus 1, 0 minus 2. And then we solve that a is equals to 3. Okay, so we make use of the information, the second part. And therefore we can then conclude that, okay, I'll write conclusion here. So therefore gx is equals to this. Okay. Okay, I erase this question now. I don't need that solution there. Reconstructing the polynomial that we want. Okay, so whenever given a question, we need to be able to break it down, identify the important information. So there are three important information here. Firstly, the term containing the highest power of x in fx is 2x cubed. Okay, so what this means is that fx, okay, is going to be a degree 3 polynomial. It will be a cubic polynomial. Okay, so this is our first info. Okay, then it tells us that the root of the equation, okay, or rather a root of the equation fx equals to 0 is -1. Okay, so one of the roots is -1. It did not tell you all the roots. Okay, so this is second piece of information. Third piece of information is that x squared minus 4x plus 2 is a quadratic factor of fx. Okay, so how do we go about solving this? Alright. With the pieces of information that we have, it is not always necessary that we go in sequence. Okay? It is not ideal in this particular question to start off with trying to apply what we have in the first statement. Okay? Because maybe you'll be thinking that fx is equal to 2x cubed plus something plus something plus something. Because cubic polynomial. Okay? Right? So maybe you're thinking of x squared, x, and then after that some constant. But you don't know what are the coefficients. Okay? Is it helpful to think about it in this direction? It isn't. Why? Okay, because in our second piece of information, it tells us that the root of the equation fx equals to 0 is -1. But I have no idea what is the coefficient here. Maybe I'll let it be A, B, and C. Okay? Knowing this part, how does it help me to find A, B, and C? Okay? Because there are three unknowns, to even try to solve it via simultaneous solving, three unknowns, you need three equations. Okay, minimally to solve it. Right? Two unknowns, okay, which is what we have usually been doing. Right? We do our usual simultaneous equation solving. It is not in our syllabus to go and do something that's 3 equation, 4 equation, 5 equation. Okay, there are more ways to solve it. Like you can go and learn it in future. I think you'll be learning in JC when you do something related to linear algebra. Okay, using matrices. But that's not our discussion today. So, thinking along this idea, it's not helpful for us to use this information. Neither is it helpful for us to use this information. Okay, because this is telling us that it is a factor. It is not saying that this is a part of this fx. It is not saying that it must be x squared, then after that minus 4x, okay, and then plus 2. That's not true. Okay? Right? It's saying that it is a factor. Then how? Okay, how do we start this equation or start this question? Okay? So let's look at the very last piece of information first. It says x squared minus 4x plus 2 is a quadratic factor. Can it be further factorized?
Yes.
Really? Can it? You think about it, Moses? Cannot, huh? Okay? Alright. X squared minus 4x plus 2 cannot be further factorized. There's no way for you to have two numbers to multiply each other to be 2 and then add up to become 4. That's not possible. Okay? So, we know that x squared minus 4x plus 2 cannot be further factorized. So what? What does this imply for us? This tells us that our root of negative 1 does not come up from this quadratic factor. Because we know that when we have the root of negative 1, right, it tells us that the factor, one of the linear factors will be what? X plus 1, right? Okay? Because we know that it talks about x-intercept, okay, root of an equation, so x plus 1 is a factor. Okay, so x squared minus 4x plus 2 cannot be further factorized, so the solution of negative 1 can't be coming out from there. Okay, so we say that since negative 1 is the root of fx equals to 0, I'll just formalize this. Then x plus 1 is a linear factor of fx. Okay, so we got point number 1 and point number 2 over here. So this was trying to imply to us that negative 1 is not a result of this factor. Okay, so with these 2 points, what does that mean? Okay, it means that I have a linear factor and I have a quadratic factor already. And I know that my fx is a degree 3 polynomial because this is the highest power. So how do I form my fx? My fx must have the x plus 1, must have the x squared minus 4x plus 2. Because remember, fx being a degree 3 polynomial, the parts, okay, of the multiplication needs to add up in terms of its degree to give us 3. Okay, 1 plus 2 must give us 3. So this is how we piece the information together, okay, to form this. But is this correct? It isn't. Why? Because, yes, they say what they want in expanded form, okay, x times x squared. I'm going to get x cubed, but will it give me 2x cubed? No. So our fx should actually be 2 times x plus 1 times x squared minus 4x plus 2. So this 2 itself is because question said that highest power of x in fx is 2x. Okay, so it's purely by fitting all the pieces together to come to this conclusion. Okay. Right. So since the question says that you want it to be descending powers of x, that means we got to expand this. Okay, so fx. To expand it, you can tackle the brackets first. Okay, so I'll leave the 2 outside. X times x squared, I will get x cubed minus 4x squared plus 2x plus x squared minus 4x plus 2. Okay. Then simplify it first. I will have 3x squared minus 2x plus 2. Okay. So in descending powers of x, that will be the answer. 2 and part 3 so that we end off neatly. Right? Part 2 to find the number of real roots of fx equals to 0, justifying answer. Take note question wants to find number of real roots, not the exact real roots. Okay? In fact, we already know one of the root is negative 1. Okay, so with fx equals to 0, we make use of the factorized form rather than the expanded form. So x plus 1, x squared minus 4x plus 2 equals to 0. Means that x plus 1 equals to 0 or x squared minus 4x plus 2 equals to 0. So this gives us one root already, which the question also told us. X squared minus 4x plus 2 equals to 0. If we look at just the discriminant, okay, we don't even need to bother to solve because the question is only asking for number of real roots. Okay, they are not asking for what are the real roots. So just by looking at the discriminant, I will find that it is negative in value, positive in value, 8, which is more than 0. So that means over here, it will generate how many real roots? 2, okay? Therefore, x squared minus 4x plus 2 equals to 0 has 2 real roots. Okay, hence, in conclusion, fx equals to 0 has 3 real roots. Okay, so everything here is the justification towards having 3 real roots. Right, so we cannot forget our discriminant. Okay? Yes, part 3 is just remainder theorem, that x equals to 3. Okay, so I will not do part 3 per se, I'll leave it to you. You should be able to get a remainder of negative 8. Apply your remainder. Okay? Now, I got a small announcement. Okay. First of all, homework first for chapter 4.3. Okay. Exercise 4.3. Homework. Question 6A. Wait up. Okay, 1B. 6D, 9, 10A, and 15. Okay, now